video. And my name is Safi, and without further ado, let's get started. So, this is Hacking Smart Contracts, how to become a blockchain security auditor. But the question that you should be asking isn't blockchain supposed to be secure? Well, the answer to that is yes and no. There's this quote that there are no free lunches. If you've been around in the blockchain space, I'm sure you've heard of the blockchain trilemma. So you can either have speed, a lot of speed, and you might have to sacrifice on security. You might have a lot of security. You might have to sacrifice on decentralization. So there's, again, like it's written right in front of you, there are no free lunches. So vulnerabilities exist across the entire blockchain architecture, I would say, except for, let's say, the encryption part of it. And even that could, if assuming quantum supremacy, quantum computers could theoretically be able to break the encryptions as well. So your public-private key pairs could also be compromised. And they can also be compromised using social engineering, as we'll see further down the line, right? So let's talk about the consensus protocol. What is consensus in blockchain, right? So if all of these, for example, are nodes, right? Let's say a new transaction comes in, and let's say about these many of them, except for this guy, all of them agree that this transaction is legit. Then the network has come to a consensus that this guy is the fake and all these are legit spider-webs, right? But for example, if this guy was legit and all of these were fakes, then we would have what is known as a 51% attack. So a 51% attack is where 51% of nodes are saying that that a certain transaction that's not real is real. Then obviously that transaction is going to be mined, and that could be malicious in nature, right? And so the consensus protocol gives us a high probability that we won't have a bad transaction mined into the blockchain. This is, again, very high level. This isn't a detailed explanation, and this isn't a academically sound diagram. Okay, so now we're going to look at an example of an insecure contract, but we're only going to be looking at a insecure contract in Solidity because it's much more easier to read and understand. So okay, so this is Ethernaut Open Zeppelin. This is a good resource if you ever feel the need to practice smart contract hacking. You learn a lot by doing all of these problems here. This is just a demonstration, so I'll put this link in the description so you guys can come and look at this yourselves. So let's see. Okay, so the objective of this level is to steal the ownership of the contract and reduce its balance to zero. And there's the ABI, which is the application binary interface, which I have opened right here, down here. And let me just go through certain things. Player address. This is my address for my MetaMask wallet. Ethernaut address is the address for the main contract for the game. Sorry. Instance address, which I made a new instance of because I was messing around with it before, is the address of this contract right here. Okay, so it has a certain owner. We can look at that owner if you want. For that, we need to make a new instance of contract. So first we need the ABI. So if you don't know what the ABI is, it's sort of like a type declaration. So if you look at here, not here. Let's see, contribute is a function. Payable, supposed to receive money, and type is, so it's basically like a type declaration of what methods does the contract have and what are the inputs and outputs expected, right? So this, and the next thing we're gonna need is instance, right? So so this is gonna need a new keyword right here. Okay, now we have our contract definition, and what we want to do is we want to call this. So the way we go about this is we go contract.methods, con.methods.contribute. So it expects no arguments, which is cool. But let's call the owner, right? Owner, right? This address right here, and there are two kinds of calls in blockchain. There's call, right, and then there's send. So if I was to compare this to a REST API, then send would be a post call and call would be a get, right? So what that means is there are only two types of operations in blockchain. You can either read from the blockchain or you can either write from the blockchain. Reading from the blockchain costs nothing, it's free to do. Writing to the blockchain costs money. The reason for that is that you're paying for the storage that you're using on the blockchain. So we're reading, so this is going to be free, which is good because we like free things. From player, okay, that's on me. This returns a promise. If you don't know what promises are, don't worry about it. Just think about this. It means, how do I explain a promise? It says that it's going to get to getting that data eventually. So we're telling it, okay, we want that data right now. Don't worry too much about it because this won't be an issue. Okay, so we know that this guy, whoever this guy is the owner of this contract. So what we want to do is we want to take the ownership of the contract from this guy to our address, which is this, right? We want to be able to take the ownership to this address, transfer the ownership to this address, and we also want to steal all the money this guy has, right? So we want to transfer all the money to ourselves. How do we do that? Well, first we're going to analyze the contract. Okay, so they're using SafeMath, so hopefully there are no overflows here. So unit 256, mapping of contributions, so address unit, this probably means which address has contributed what amount of Ether. Public payable owner of the contract. So the constructor is called when you deploy the contract. So when this person deployed the contract, they set themselves as the owner and they've put in 1,000 Ethereum here. This is a modifier saying that only the owner can call it contribute. Okay, what is it doing here? You can only contribute less than 0.001 ETH, and if you contribute more than the owner, then you can be the owner. This is a joke. So you could never do more than 0.001 Ethereum, and if you want the ownership of this contract, you'll have to add more than 1,000 Ethereum to be the owner of this contract. But this is what this function is saying. But that's impossible because you cannot put in more than 0.001 Ethereum. Well, that sucks. How are we going to get the ownership now? Okay, get contributions. We can get how much contributions they are. Withdraw, transfer all the balance that this contract has to the owner. And this one is the special one. It says the message value has to be greater than 0, and it has to be greater and the contributor has to be greater than 0, so it cannot be 0. So if you send greater than 0 Ethereum to this function, and if the contributor has greater than 0, and if you contribute it to the contract, you can be the owner. So this is what is known as a fallback function. What a fallback function is if when you send Ethereum to the contract, not calling any methods here, if you just send Ethereum, it's going to this function is going to be triggered. So from this we can be pretty sure that if we contribute less than this, and we have our address in this contributions mapping, and then send some non-zero Ethereum, we can get the ownership of this contract. Okay, let's try that. We have the contract. Let's say dot methods dot contribute dot send. Send again is writing to the blockchain from player who's sending the transaction value, and let's say two-way. I'll explain two-way in a bit. 0.0000, very small amount, and let me just show you guys something. These are all the helper functions that we have. Sorry, these are all the helper functions that we have here. And if you play around with all of these problem exercises, you'll be able to use these, right? So we want to add a weight here, and it should pop up Ethereum. Awesome. We are going to send this, and we don't want to wait too long. So what we do is we'll just speed it up, add more, and probably it'll do it less than 15 seconds. And after this is done, we'll check our contributions. Okay, so it's done. Let's check contributions. Get contributions here, paste, enter, and this is the amount that we put in. So from way, yeah, this is the amount that we put in. So if you don't know what a way is, you can Google units in Ethereum. It'll take too long to explain. Okay, so now we want to take the ownership, so we're going to send this exact amount, send transaction, which is also a helper function in the helps in this library here. So what we're going to do is we're going to specify 2, which is going to be the instance, and we're going to specify from, which is going to be the player, that's us, and we're going to specify the value, which is going to be this one, right? And I'll just add a weight here and send transaction. We're not able to estimate gas. I want to proceed anyways. Oh, this is too many. Oh, I messed up. Hold on. Yeah, obviously I don't have that much. This is supposed to be 0.00001, right? Because it's in way, so it's in Ethereum, and we're converting it into way. Okay, confirm, and the transaction has been sent. We'll try to speed it up, put it maximum. Hopefully it gets done quickly. So what's going on here is this is stored in what is known as the mempool, and is waiting for a miner to mine this transaction, confirm it like we looked in the previous slides, and put it into the blockchain. Okay, it went through. Now what we want to do is we want to check if we're the owner or not, right? Fingers crossed. Owner. Okay, and okay, this is not the same as before, so let's check. This is our address. Okay, where we've gotten the ownership, we've successfully hacked this smart contract. So what we're gonna do next is we're gonna withdraw. We're gonna steal money, which is fun, which is the fun part, right? So con dot methods dot withdraw dot send from, oh sorry, this needs to have these curly brackets, excuse me, player, which is us, and send. Oh, my bad, we didn't specify the value because we don't need value here. Confirm, because this is not a payable function, right? So we only pay for the gas. Okay, we're waiting for this transaction to go. We want to speed it up. Save. Now we're waiting for the money to be sent into our account. And there we go. We can look at what's been done here. And we've successfully managed to hack this smart contract. Okay, so now let's look at a social engineering example. This is the Axie Infinity hack that happened, I think this year. I don't exactly remember. I'll link link to this article. It will be in the description below. So what happened was some guy from Axie Infinity received a job offer for a substantial amount, and attached with the PDF was a spyware. So the spyware, I believe so, the spyware was able to find the private keys of Axie Infinity, and they were able to take out a lot of the crypto that was stored there. If you've ever joined a Discord server for any NFT project or any crypto project, you'll see that a lot of the times there are people coming there and saying, hey, we'll give you XYZ amount of crypto or XYZ amount of NFT. You just need to send us your private key. Never send anyone your private key, because this is called asymmetric encryption. So you can get the public key from the private key, but you can never get the private key from the public key, right? So your public key is like your address. The private key is like your password. So if you can get access to anyone's private key, then absolutely you could hack into their accounts. And there are some projects, what they've done is, some fake projects actually, what they've done is say, hey, just add in your private key and our bots will make money for you. And they have all of these fake results that sort of like validate people's, validate that, hey, our bot is making money, but what they're actually doing is they're running a Ponzi scheme and stealing money from other people's account. So be very careful with your private keys. So okay, so what this course isn't, and what is this, right? So this course, it won't be an in-depth smart contract auditing course, but rather would be a bird's eye view of smart contract auditing across multiple blockchains. What I want to be able to do is, what the objective of the course is to introduce smart contract auditing so you guys know what you don't know, so you can go learn on your own for free. There are multiple resources, and you can mess around with things and figure out a lot of these things on your own. So what blockchains are we going to be looking at? We're going to be looking at Ethereum, Bitcoin, Cardano, Solana, Polkadot, Tezos. I will try to keep my opinions out of the way as much as possible, but I do think Solana sucks. and I will repeatedly belittle this blockchain because I do not like it. I will explain in more detail later, but it's more of a personal grudge against it than anything else. I do not think Cardano sucks, as a lot of people do. I think Cardano is actually one of the more secure blockchains in this list that has smart contracts. And why is that? I'll explain that in a bit as well. In the next videos, probably. So the programming language that we're going to be looking at is Solidity. Bitcoin does not have smart contracts, but it has scripting. So you can write scripts to send and receive transactions. We'll take a look at that probably, but you don't need to know any of these programming languages to follow along. You just need to have an understanding of how blockchain works. Or if you do, then awesome. Then you can dive further into any of these, whichever you like, and get really, really good at it. So if you this course is for you if you understand blockchain development. If you're familiar with software development and have an understanding of blockchain, you can still follow along. If you're not technical, then you might get some entertainment value out of this, but in terms of maybe you could also learn how to use a few tools that we're going to talk about in the Ethereum series of videos. But I don't. But yeah, if you want to waste your time, be my guest. So why would you take this course? Because everyone needs smart contract auditors. Every company needs smart contract auditors, and if you've really mastered this skill, then you'll get clients like instantly, because there's too many. Because everyone needs good smart contract auditors, and there are a lot of hacks that happen. And if you go down this route, a lot more clients coming your way. That's it. I hope to see you guys in the next one.